So in this unit we will see about the balancing of rotating masses. So as we all know about that, the machines have rotating and reciprocating masses. So if the rotating and reciprocating masses are not properly balanced, so it generates unbalanced forces. So the unbalanced forces and unbalanced couples are dynamic in nature. Due to these unbalanced forces, the machines will be vibrate. So result of these vibrations, running life of the machines will be come down. So overcome of this vibration, we go for balancing. So the balancing is the process of designing or modifying machinery so that the unbalance is reduced to an acceptable level. So and if it is possible, eliminate entirely. The types of the balancings are the balancing of rotating masses and balancing of reciprocating masses. So in this slide, the balancing of rotating masses consists of four methods. One is the balancing of single rotating mass by a single mass rotating in the same plane. Balancing of single rotating mass, two masses rotating in different planes. The balancing of different masses rotating in same plane. The balancing of different masses rotating in different planes. In this slide, the balancing of single rotating mass by a single mass rotating in the same plane. We consider a disturbing mass attached to the shaft, that is M1, and rotating at a angular velocity omega. R1 be the radius of the rotation of the mass M1. So the centrifugal force acting radially outward thus produce the bending moment of the shaft. In order to avoid the effect of this force, the balancing mass may be attached in the same plane of rotation, as that the disturbing mass such that the centrifugal force due to two masses are equal and opposites. So in this slide, the balancing of single rotating mass by two masses. The two masses are placed in two different planes. The two masses are parallel to the plane of rotation of the disturbing mass. It satisfies the two main conditions of equilibrium. One is the net dynamic force acting on the shaft is equal to 0. That is a condition for static balancing. And the second one is the net couple due to the dynamic force acting on the shaft is equal to 0. That is the algebraic sum of moment about any point in the plane is equal to 0. In this diagram, the M is the disturbing mass placed between the M1 and M2. The M1 and M2 are the balancing mass. It is parallel to the axis of rotation of the disturbing mass. So in this slide, the balancing of several masses rotating in the same plane. We consider the four masses M1 and M2, M3 and M4 at a distance of radius R1, R2 and R3 and R4 from the axis of rotation of the shaft. Let theta 1, theta 2, theta 3, theta 4 be the angle of the masses with respect to the argent line OX. So in these four masses, we resolve the four masses. We find out the resultant mass of four masses, and the balancing mass is attached to the resultant mass in the opposite direction and with equal magnitude. In this side, the balancing of several masses rotating in different planes. The several masses are placed in different planes. We consider the one of the masses as a reference plane. So this technique is to transfer the centrifugal force acting in each plane to a single parallel plane. So the procedure of this balancing is almost same as the different forces acting in the same plane. So the complete balance of several masses in a different plane, we follow the two conditions must be satisfied. The forces in the reference plane must be balanced. The resultant force must be equal to 0. And the second one, the couple about the reference plane must be balanced. The resultant couple must be equal to 0. Thank you.